This is an example problem for our midterm exam review for the exam. Okay, so then we're going to ask, what is the force of gravitational attraction between the Sun and Neptune? Okay, so we have a force of gravity, so now I know my Newton's universal law of gravitation is going to work here. So I've got the Sun and Neptune. So just to kind of get a visual, I'm going to do a quick diagram. So over here, I'm going to put the Sun, and then here is a sketch of possible orbit for Neptune. And I'll put Neptune maybe right here, not to scale, Neptune. Okay, so then the Sun pulls on Neptune with a force, and Neptune also pulls on the Sun. So this is a Newton's third law pair. These masses are attracted to each other. They're pulling on each other. So this obeys Newton's third law. Now the strength of the force is given by Newton's law of gravitation. So we have two masses attracting each other, separated by a distance, and then multiplied by our constant. So this problem says, what is the force? So I'm asked for a force. So in order to get this force, I know I need these four numbers, G, M1, and M12, and D. So I'm going to start making a list of what I need. Okay, so where do I get these numbers? Okay, so big G, that's a constant that's given to you on the test. So you will write it down from the test document. Meter squared per kilogram squared. Okay, mass 1 and mass 2, those are the masses of my two bodies here, Sun and Neptune. So it doesn't matter which one you put as mass 1 or mass 2. So where do I get the masses? From the table that is given to you on the test. There's a data table. So I look up the mass of the Sun, 2.0 times 10 to the 30 kilograms. And then from the data table, I look up the mass of Neptune. So 1.03 from the data table times 10 to the 26th kilograms. Okay, the separation distance that will be given to you on the test, 4.51 times 10 to the 12th meters. Okay, so I have the four numbers that I need. I just need to plug them into the formula carefully. So my plug-in step, okay, so I've got a big fraction here. So I'm going to plug in big G, 6.67 times 10 to the minus 11. Mass of the Sun, 2.0 times 10 to the 30. Mass of Neptune, 1.03 times 10 to the 26. Okay, so there's my numerator. On the bottom, I take the separation distance, and I have to square it. So I'm going to plug in this number and square it. 4.51 times 10 to the 12th squared. Okay, so now to get my final answer, I'm going to go to my calculator. Okay, so notice on this calculator, there's this button that says EE. That's going to help us do scientific notation. So entering in our numbers to do our math. So here comes gravitational constant. So the coefficient, 6.67, enter that first. Then you hit EE. Now it wants the exponent. So the exponent is, on the 10, is negative 11. So this says to the computer, 6.67 times 10 to the negative 11. Coefficient, exponent. Okay, so now this number's entered. So now I multiply by mass of the Sun, 2 EE30, 2 times 10 to the 30. Then I multiply by the mass of Neptune, 1.03 EE26. Okay, so then that's my numerator. Now I'm going to divide. So I hit divide. Now I'm going to enter in the separation distance, 4.51 EE12. Now I'm going to square that, and then I hit equals. And there's my answer. I'm going to round this to 3 digits here, 6.7. That's going to round to a 6. 6.76 is my coefficient, and then my exponent on my 10 is 20. So now I'm going to go back over to the board. I'm going to round off my answer to 3 digits. 6.76 times 10 to the 20. Now this is a force, so my units are newtons. So boxing my answer with units and finishing with a sentence. The gravitational force of attraction between the Sun and Neptune is
6.76 times 10 to the 26th newtons.
Okay, thank you for watching. There you go.